Good afternoon and welcome to a Delta Math walkthrough. You'll notice this is a nice juicy Delta Math assignment. There's only 5 questions in it and they're all of one type. It's Friday, so take it a little bit easy, everyone, and let's go for it. So we're going to take a look at how to solve these more challenging trigonometric problems. And it starts with good diagrams, so we'll see. Okay. So in order to have a good diagram, I need a good piece of paper. This is a great piece of paper because I can overwrite it an infinite number of times and just keep erasing. Okay, so let's start with our diagram. Our boat. A boat heads out to sea starting at point A. So draw a boat. Okay, a boat. Okay, and it's at point A. Right? At a horizontal distance of 1,206 feet from a lighthouse or the shore. So let's draw a lighthouse. Lighthouse. And how far is that? That is 1,206 feet. Okay. From that point, the boat's crew measured the angle of elevation to the lighthouse beacon light to be 9 degrees. This is 9 degrees. Okay. At some time later, the crew measures the angle of elevation from point B to be 4 degrees. So find the distance from point A to point B. Okay, so the sharp ones among you will already realize that I now need to draw the next boat over here. So this is a really useful piece of paper because watch what I can do. I can do this, I can drag it over, and there's infinite paper that direction and that direction. It's very cool. So if I put over here point B, now let's take another color to be my B, and I think orange will stand out very, very well against that blue. So over here, the boat has moved to point B. How do I know that point B is farther away? Well, if I'm very, very close, the angle will be very big because I'm looking up almost straight up at the lighthouse. As I get farther and farther away, the angle gets smaller. So that's how I know to put point B further away. Okay, so now point B is like this. Looking at the lighthouse this way. So that's triangle B, and this is 4 degrees inside their little angle. Okay, so now I have point B, point A. Let's call this point L. Okay, and then this is lighthouse, and then up here we'll call this what point? A, B, C, F, G, H, I, J, K, L, M. We'll call it M just because it's alphabetically next after L. Okay, so now I'm going to draw 2 triangles, and they're going to be a little nicer drawn. Notice they're not to scale because drawing a 9-degree angle is a little annoying. So I'm going to draw a bigger angle than that, but label it 9 degrees and remind myself that this is always a right angle. So this is triangle A, L, M, and it has a known distance here of 1,206. And this is some height of the lighthouse. I don't know how tall, so call it H. Okay. And then here's another triangle. This is now 4 degrees, so a very shallow angle. I'm not drawing it to scale. I'm making no attempt to draw that to scale. This is height H. This is still M and L, but this is now point B. Okay, this is some unknown distance D. And the thing that I am trying to find in this problem is the distance from point A to point B. Round to the nearest tenth of a foot if necessary. I'm sure that's going to be necessary. So here, what I'm looking for is D minus this. So that will give me the distance between A and B. See, here's D here. This is side D all the way from there to there. That's side D. This side on this triangle that I've represented there. Okay, so if I take D and I subtract this, that will leave me with that. So what I'm going to have, what my desired solution is D minus 1,206. So I want to find D. But I look at this, I've got a triangle, I have one known angle and no known sides. So I'm going to need to do some work somewhere else. Okay, here I have a known angle, a known side, so I can solve for that. Once I've solved for that, I substitute it into this diagram here. So let's go for it. Here I am relating opposite to adjacent. This is opposite the angle, so I have tan, because tangent relates opposite to adjacent, tangent 9 degrees equals h over 1,206. Okay, and so if that's 1,206 feet, my guess is that that's going to be much, much shorter than that, but that a lighthouse should be about 75 feet or something like that. So I multiply both sides by 1,206 tan 9, and that will give me h. Let's go ahead and punch that on my calculator. 1,206 times 9 degrees tangent equals 191 feet. Well, my estimate was really bad, but who cares? Okay, 191. I'll remember for next time. I didn't think about it very hard. 191 point, and I better keep some decimal places because they want this to the nearest tenth of a foot, as though that's important. 0.011. So I'm going to use 0.01, and that's plenty of detail. Plenty of detail. 0.01 is equal to h. Okay, take that, substitute it in here. 191.01, and I can even, if this is there, that's now erasing that h. Now I can solve for d. Okay, so let's do that. Tan 4 degrees. Okay, so now I'm working with 4. This is the opposite. This is the adjacent. Is equal to 191.01 over d. And so it's a real banger, eh, this song I'm humming. All right, so then d, I move it up here. So I'm going to multiply both sides by d. So I have d times tan 4 is equal to 191.01. See, I multiplied both sides by d, so it came up there and canceled on its side. And now I divide both sides by tan 4 so that I get d is equal to 191.01 divided by tan 4. And if you've done so much practice now that you just take these two things and do a quick switcheroo, because you know that's how this works, that's fine. If you know that that's going to work, that's what we'll punch on our calculator. And that will give us D. Remember, that's not the answer. We have to then subtract 1,206 from it. So let's go. I already have on my calculator this number accurate to many decimal places. You see, that's already accurate to many decimal places. I might as well work with that. Divide by the tangent of 4 equals. So now the boat is 2,731.59 meters away. Okay, so that is this distance, total distance from the lighthouse. Let's subtract its original distance, minus 1,206. Equals this to the nearest tenth of a foot. Well, it's that, but it rounds up because the 9 rounds up the 5. So we'll go here. Nearest tenth of a foot, so paste that in. Desmos does not like commas, so don't put a comma in for Desmos. It will tell you don't do that. Push enter, enter. Hooray! So let's say draw a diagram. Their diagram's so beautiful. Okay, find the height of the small triangle. Okay, so you have to find this height. They call that the opposite, the adjacent. They called it x. I called it h. Who cares? It's a letter, all right? It's arbitrary. And then they boom, boom, boom. They had this, we had that. Then they find the base of the big triangle. That's the opposite, that's the adjacent. So they say tan 4 is equal to this over y. They multiply both sides by y. And then they divide both sides by tan 4, which is what we did. We punched this on our calculator directly because we're really sharp and smart. And then they got that with lots of decimal places of who cares about that level of detail. We don't want it to the nearest molecule or the nearest width of an electron or something super tiny, which we would get by probably about there in decimal places. Maybe even earlier, maybe there, I don't know. And then we subtract to find the distance from a subtract. That's how you do these. You want me to do one more example? Sure. Okay, I'll go faster. Don't worry. No problem. Paisley is trying to find the height of a radio antenna on the roof of a local building. She stands at a horizontal distance of 22 meters. Just clear my canvas. Very easy to erase my canvas. Okay. And height of a radio antenna on the roof of a local building. Okay. Okay, cool. So here is the building that Paisley is looking at. Okay. And this is the correct way to draw a skyscraper. All right. And there is a radio antenna, which looks like this on top of the building. Okay. There's the radio waves coming off of the radio antenna. And she is 22 meters from the building. And when she looks up here, she's looking up at what height? 29 degrees. All right, and in another color, we'll do the other triangle. When she looks up at the top of the radio antenna, that's a total angle, not just the difference there, but the total angle of 42 degrees. I believe those are all the numbers. For eyes are 1.74 meters from the ground. Oh, okay. So now we need to remember that this is from Paisley's eyes. All right. And Paisley's eyes are above the ground. Just going to extend my building here by a rectangle. We don't need to do trig on rectangles. That's good news. So this height here is 1.74 meters. 1.7.4. What is that, Mr. Jennings? I can't erase that precisely enough with this eraser tool. There we go. That's 1.74 meters. We're working in meters here, so maybe a Canadian created this question, or a Brit. All right. So that's 1.74. We can find the height here above her eyes to the top of the building, and then we can find the height here to there, and then we'll be able to use subtraction to find the radio tower. So we want to find the height of the antenna. Okay, so this is what we desire to find. We desire this height. Okay, how tall is a radio antenna? And to do that, let's draw two triangles. The first one we'll do in black to match this triangle. This is super tricky. You don't need that number at all. Find the height of the antenna, distance from point A to point B. Yeah, yes, we just want to find the height of the antenna. So this doesn't matter one bit, okay? It just doesn't enter into the question at all. So that's a red herring and piece of information. So this is a right angle, okay? So let's label it. This is P for Paisley's eyes. This is Q for that point on the building. This is R for this corner, and this is S. Okay, so now I can create triangles. So here's triangle PQR, 29 degrees, 22 meters, right angle here. This is Q, this is R, that's the top of the building, and this is P for Paisley's eye. Okay, and so then I can find the height of, not the height of the building, but just the height up one side of the building. And then I can have, here, just going to maximize, I can create another triangle in orange to match my colors. Here, this is triangle PQS. And this is 42 degrees. This is P, this is Q, and this is, oh, I called that H? No, let's not call that H. Because I called the height, the desired height here, H. So I'm going to call that HI. I don't like I, so I'm going to call this length J. RQ is length J. And so this is length J plus the desired length H. Okay, that's H plus J. And I'll just put J on our diagram there. That's this height up the side of the building. Okay, this is still right angled. Okay, so now, and then at the top there, what is that? That is point S. Okay, so now let's do math with this triangle. Move the paper over. Okay, let's find J. J equals, why do we want to find J? Because we want to find this, and then we're going to find that, and then we're going to subtract this from that to find H. Okay, because H is equal to all this together minus J. Okay, so J is equal to, well, J is the opposite, so J over 22 is equal to tan 29 from here. Opposite over adjacent, tan 29. So J is equal to 22 times tan 29. So let's do that. Clear everything. 22 times 29 tangent. Did I say I was going to go fast? Okay, so that is there. 12.19, so 12.2. J is equal to 12.2 meters. Okay, now let's find H plus J. So here, We already know that this is 22. That's another known. H plus j over that. So if we have, let's call this a hij,k. Let's call this together equals k, okay? Because that just saves me writing it down in a funny way. K over 22 equals tan 42. Okay, this angle, its tangent is this over this, so k over 22. So k equals 22 tan 42.
Another one just referred to him as the first of the Bowser brothers. But if you don't trust these sources,
Hey Zara,
even more direct one.
I know, you got something super interesting to tell me about Super Mario, but can you wait? I'm just making a video.
Did you know that the video game that we do not play as much with, we play the Square Mario?
Yeah.
It's actually a last level where you might see a blue Bowser, a green Bowser, but if you kill it and you see it transforms into something else, it's a fake Bowser.
Yeah, it's his brother or something, right?
It's not a brother.
Oh, okay.
Only if you kill him and he just kills and he's blue and he doesn't, and he's actually just blue and he kills him the way he is made, then it's a Bowser's brother.
Super Mario Complete Encyclopedia. And when it came to this other Bowser, it had this to say. He's Bowser's younger brother. And then later described him as the younger of the Bowser brothers. And of course, when the game came to America,
So that is our answer to the nearest tenth of a meter. That would be 7.61. So I'm just going to grab that, throw it into delta math, round to the nearest meter if necessary. Well, 7.6 would round to 8, not 80, 8. So the height of the antenna is 8 meters. Enter. Yay! So let's draw a diagram. Okay, look, there's their diagram, similar to ours. 29 degrees and 42 degrees. Okay, so we didn't really use that gap in the angle, but if you wanted to find that angle, you could. And then if you knew one of these lines, then you could use sine law from next chapter, but it wouldn't save any time. This way would be good. Find the height of the big triangle, find the height of the small triangle, and then subtract.
Wow, that's blue.
And that's how you do it. This is exactly the same thing we did. Yeah. Done. Okay. So, everyone, I hope your practice is fruitful today. And if you have any questions on this Frigid Friday, find me in the chat or find me by email. Bye for now.